Okay, so the actual Pythagorean theorem says in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So remember, we kind of went over this last semester. In a right triangle, and this is going to come in handy a lot throughout this unit, the longest side there, that's the hypotenuse. Okay, the hypotenuse is always the longest side. It's always across from the right angle. So if you were to draw a line straight across, that's from the right angle, that's the hypotenuse. Remember, the legs are the other two sides. Okay, A and B are the legs. I don't know why it's not focusing. So, with Pythagorean theorem, we're going to use it a lot in this unit. A squared and B squared equals C squared, or C squared equals A squared plus B squared. Make sure you know it. It doesn't really matter which leg is A and which leg is B. Okay, but we're not always just going to be solving for C anymore. In this first example, though, if I set it up, find the length of the hypotenuse, which one do you want to be A, 7 or 24? 7. So 7 will be A, 24 will be B, X is C. So when I solve this using the Pythagorean theorem, I'd get 7 squared plus 24 squared equals X squared. You can interchange the 7 and the 24 if you want. Your answer, we're going to end up simplifying the radical as much as we can. Now, I know most of you know 7 squared. You may not know 24 squared. You can do it in the calculator as one step if you want. Okay, 7 squared and 24 squared. So I get 625 equals X squared. And then what's my last step? How do I get rid of a squared? Good. I'm going to square root. Now, I always plug it in to see if it's a decimal or not. If it's a whole number, like this ends up being 25, we'll just leave it like that. If it's not a whole number, we're going to have to simplify the radical like we did yesterday. Okay? So, like I said, our problems are not going to be that easy all the time. In example 2, now we're going to throw in a story problem, because you already know how to do this. So here we have a 6-foot board resting underneath the doorknob, and the base of the board is 5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? So we have a picture here. So what do you think is the hypotenuse? X, 5, or 6? 6 is going to be our hypotenuse. So 6 is C. X would be either A or B, and 5 would either be A or B. Okay, always figure out which the hypotenuse is. You can either look for the longest side or the one across from the right angle, if you can't figure it out. So now we're going to set this up. You're going to get X squared plus 5 squared equals 6 squared. So now we're not solving for the hypotenuse. We're solving for a leg. This one I think we can do on our own. What's 5 squared? What's 6 squared? So what would be my next step? I can't just add them together. What do I got to do next? I have to subtract the 25 from both sides. So X squared equals, I always want to say 9, and it's not. 11. So my last step is to take the square root. So X is the square root of 11. Do we know the square root of 11? It's a decimal, and we can't simplify it. So we're just going to leave it square root 11. Just make sure you put units. So X is the square root of 11 feet. On your quiz on Monday or Tuesday, I tried to make sure to go through, and if I want you to leave your answer like this, I tell you leave your answer in simplified radical form. If I want a decimal, I wrote leave around to 2 decimal places. Okay, the majority of the time, if it's a story problem, you can use a decimal. If it's not, I want simplified radical form. Okay. Questions so far? Not bad. Now, example 3 is going to show up a lot. So, Find the area of an isosceles triangle with side lengths 16, 17, and 17. So, an isosceles triangle, kind of draw yourself a sketch. Looks like this. In an isosceles triangle, two of the sides are the same. We're going to make it this side is 17 and this side is 17. And 16 is going to be our base. So it says find the area of this triangle. Do you guys remember the area formula for a triangle? Length times width times a half, or a half base times height. Remember that? So here's the problem with our isosceles triangle. The base is 16, but we don't know the actual height of the triangle. 17 is not the height. The height of the triangle should be a 90-degree angle with the base. This is actually the altitude that we talked about in chapter 5. So this problem has two steps. The first step is to find the height. Okay, that's our first step. We have to find the height. To find the height, we're going to use Pythagorean theorem. Because if I take this triangle and I cut it in half, you get 8, 17, and that's our height. Okay, do you see how it went from 16 to 8? Because you're basically looking at only at half the triangle. So our first step is to find h. We already know b, that's 16. So now we got to find the height. A height is the leg. So we're going to have to do h squared plus 8 squared equals 17 squared. So 8 squared. What's 8 squared? 17 squared. 289. And then we can subtract. H squared equals 225. And then take the square root. This would be the one time that I would be okay with you putting a decimal. Because now I got to take that 15 and I got to plug it into half the base times the height. And if this was like the square root of 11, it would be really weird to multiply. So this would be the one time on your quiz I'll put like, you can leave your answer rounded 2 decimal places. So I really wish this thing was not here. Area is half the base times the height. So the area of the triangle is half. The base is 16. That's the bottom. The height is 15. So if you want to put this in the calculator, you can always do 0.5 as a half. Times 16 times 15. So the area here is 120. Do you guys know what units are for area? It's going to be meters squared. Meters squared. The reason it's squared is because we basically multiplied 16 meters times 15 meters, and meters times a meters squared. Think of like painting, they talk about square footage, that kind of stuff, so meters squared. Okay, question so far. I want you to take a second and see if you can do example 4. You don't need to identify. Find the unknown side length for A and B. And then for C, do what we did up here. Find the area. So take a couple minutes, see if you can do all 3 of these. Alright, I know some of you are still working, but here's the answers for A. I checked around, everybody got A right. The only thing is some of you just left it as square root of 75. Remember, square root of 75 is 25 times 3, so 5 root 3. Okay. B was 39. And then C ends up being 540. So if you didn't get that far, make sure you write it down. So basically think of C as 2 steps. That's why I have a 1 and a 2. The first step is to find the height. The second step is to plug it in. Okay, and make sure you put units. When you have your quiz next Tuesday, all 3 of these will show up. Okay, there's an area 1, and then there's, this one was finding a leg, this one was finding a hypotenuse. Okay, the last thing I just want to talk about are Pythagorean triples. A Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. Now, these are like the 4 most common. Basically, if you memorize Pythagorean triples, it's like a shortcut. You end up not having to do Pythagorean theorem. If you know, like a 3, 4, 5 triangle always works. Like 3 squared plus 4 squared will always equal 5 squared. Or any multiple. So if I multiply this by 2, 6, 8, 10 always works. And I could keep going. 5, 12, 13 is a Pythagorean triple. 5 squared plus 12 squared will always equal 13 squared. Now, here's the thing. You do not have to memorize these. These are just for like the students that want to memorize them. You'll find that I end up using a lot of these on your homework and your quizzes and your tests. Okay, but it's not something that you need to necessarily know. Worst case scenario, you just do Pythagorean theorem. If you memorize the 4, I think there's more, there's a bunch, you can Google them, but these are the 4 that we use the most. And then they're multiples. So if I have a 5, 12, 13, but I see 10, 24, then I know the hypotenuse would be like the 26. Again, I knew them only because I went and did a lot of math, because that's what my degree's in. But if you guys don't want to memorize them, feel free not to. So if I'm looking at example 5, and I don't have Pythagorean triples memorized, I'm going to have to do 30 squared plus 40 squared equals x squared. But if I know my Pythagorean triples, which Pythagorean triple do you think this works with? 3, 4, 5, right? Because it's 3, 4, 5, but it's times 10. So x is just going to be 50. And then I don't even have to do Pythagorean theorem. Okay, but like I said, this is like one of those things, if you want to know it, you can know it. If you don't worry about it. Same thing with b. If I was trying to figure out b, if I didn't know Pythagorean triples, I would do x squared plus 48 squared equals 50 squared. If I knew Pythagorean triple, let's see, if I cut 50, oh, look, 7, 24, 25 times 2. So this is a 7, 24, 25 Pythagorean triple times 2. So then x would just be 14. Okay, so it's really up to you. It's whether or not you want to know these. Like I said, there's only really 4 that we look at a lot. 3, 4, 5, 5, 12, 13 show up the most. And multiples of that. Those are the ones I picked the most. These are a little bit second tier, and then there's a bunch that we don't really ever use. Like, look at that last page. 8, 15, 17 showed up. Here, 7, 24, 25 showed up. Okay. For showing work for Pythagorean triple, just tell me which one it is. And you're fine. Okay, questions?